Hello and welcome to the next session. So, in the last session I was talking about the overfitting problem in our neural network or deep neural network or machine learning algorithm. So, how to avoid the overfitting in our data science or model? So, what we do is we take a multifold approach. So, I have a data set. The data set will be broken into three parts. One is a training, another is a testing, and a third is a validation part. So, what I do is I take a portion of the data for a validation part. Next time I take another portion of the validation data, another set of the data, and another set data. So, you can see that entire data set has been used for a cross validation. So, first time my set fold number 1 was validated, second time fold number 2 is getting validated, and so third, and so is the fourth. So, every data has a very good chance for a validation. So, this is the way we use it. So, cross validation has one main drawback. It requires significant more computational resources because I have to randomly select the fold, okay, to access the model quality. In our example, to make a single assessment, we needed to fit 3 models. With a regular train and test split, we could have done with the only one model. In addition, cross validation accuracy will grow with the number of iterations you go on a fold. So, more folds you have, accuracy is going to increase. So, cross validation allows us to use more data for training while requiring more computational resources. So, you have a trade off. How do we choose between cross validation and trail validation? That is what we call as the test splits of the project course. Okay. So, if we use a cross validation, and whenever you are using a cross validation, you go for a small to medium size data set, and I am showing you a table here. The table corresponds to what is the size of my data, small to medium. Then you go for a model training, require low model computational resources and time, then you go for a cross validation. If the model data set is very large, okay, then you go for a model training, require lot of computational resources and take a longer time. So, either you can use a validation technique, or else you go for a train, validation and test as a 3 split part. So, normally we go for a larger data set, or in case of my deep neural network where the data set is very large, I will go with the 3 training data, validation data and the testing data. So, this is how we do it for our work. Then let us see how do I measure my metric of my performance. So, as I said before, any model which is being implemented or being used for the deep learning or machine learning has to undergo a stringent test. So, the testing has to be done, and for measuring the performance of my model, I have to have some metric parameter. So, one of the metric parameter which we know from our probability theory or any other theory in our earlier mathematical books and classes, root mean square error, or RSME, is equal to RMSE square root of summation 1 to n predicted value minus actual value, and take the difference and square them and divided by n. Okay. So, n is the total number of data points in my data set. Predicted minus actual is the error between the two. So, if the predicted and actual are very close together, then my error will become reducing and reducing. Okay. And the sigma sign at the end of the formula means the entire sum. So, you take the entire sum of a predicted minus actual, square them up, because it may be negative, it may be positive. So, when we are squaring, it will become positive and then square root of a positive. Okay. So, another popular way to measure a regression error is called as a mean absolute error, MEE is equal to 1 by n. So, you are taking an average of mod of predicted value minus actual value, sum them up. So, you take your value, your predicted minus actual could be negative, but the error has to be positive treated. So, that is why we always take the mod operation. So, with this we can use a MEE or RSME to measure our performance of the model, which you already are aware of. Okay. So, a beautiful way of making the how a model is performing. We generally try to have a higher accuracy, but do you think that accuracy is always a good term to know the model performance? Sometime yes, sometime may not be true. Okay. So, let us see an example and then we will come to a conclusion. If I define accuracy is equal to n correct divided by n, what is n correct? Here n correct is the amount of correct predictions done by the model, and capital N is the total number of predictions available in the data set. So, accuracy is simply understand to calculate, but it is a major flaw. The flaw is, let us assume that a average probability of having a pneumonia is equal to 0.001%. So, a normal tendency of having a pneumonia in a city or in a country is equal to 0.001%. That is, 1 person out of 1 lakh has only one illness. But if you have collected a data on 20 or 2 lakh people, it is feasible that your data would be containing only 2 positive cases. So, you are only having 2 positive cases where the probability is equal to 0.001. So, imagine you have asked a data scientist to build a machine learning model that estimate the pneumonia probability based upon the patient data. So, you would say that you would apply only accept an accuracy of no less than 99.9%. That means you are close to 100%. So, suppose that someone created a dummy algorithm that creates a output equal to always 0. This model has no real value, but its accuracy in our data will be very high. So, you can see that accuracy is equal to 2%. So, you have 1,999,98 divided by 2 lakh and 99.999. So, the problem is that accuracy considered only a global fraction. So, the problem with calculating the accuracy is, I am taking the entire data set, what about the sample? So, this is a big problem. So, the problem is that the accuracy always consider only global fraction of the answer. When one class outnumbers the other class, accuracy is a misleading values. So, this is the problem with the metric measurement called as accuracy. So, accuracy will not give you a correct picture of the model performance at many of the time when the classes are imbalanced. What is meaning by class imbalance? Very simple. If a class has 95% positive, then it should have a 5% negative. Is it a class balance? No. The reason is 95% will outlay the 5% which is not there. So, your class imbalance will give you a wrong accuracy measure. So, you have all the time 95 divided by 100. So, that is a major problem. So, what we have to do? We have to make the class as a balanced class. So, if you have a 50-50 both of them, then you have a fairly good chance of achieving a better accuracy results. So, this is how a accuracy one. Okay. So, the problem is that accuracy consider only the global fraction of the answer. When one class outnumbers the other class, accuracy output are always a missing or misleading values. So, let us look at a model prediction in more closer detail by constructing a confusion table. Now, confusion table is always confusing to all of us. What is a confusion table? True positive, true negative, false positive and false negative. These are the definitions of my confusion table which we know already. Okay. So, let us say that I have a confusion table and the confusion table tells me a term equal to true positive, true negative, false positive, false negative. So, let us see how we work. So, if I have a confusion table and the confusion table is equal to, we call, let me define the 4 abbreviations. True positive. True positive tells me that how many cases were true and how many were reported as a positive. So, if I say I am coming to the college, true, coming is positive, so it is a true positive. I say I am not coming to the college, true but negative. Okay. So, similarly you can have a false and false negative and false positive. A person does not have a pneumonia, but you have predicted is correctly as having pneumonia, false positive. Okay. The person has a pneumonia, but you have corrected you have detected as does not have a pneumonia, so false negative. So, this kind of diagnosis are a big problem in our machine learning algorithm, and that is how we solve the problem using a true positive and true negative. Okay. So, suppose that you have a problem and the real pneumonia cases, a model prediction has a pneumonia equal to true and model prediction does not have a pneumonia equal to 0. Real outcome does not have a pneumonia equal to 30 and the real model has 199.968. So, this model correctly identified 2 cases as true positive value. This is a clear improvement over the, okay. So, however, the model also identified 30 people, okay, 30 people as having a pneumonia while they were not ill in reality. So, this is what we call as a our matrix wrong calculation. So, we call such an error as a false positive prediction, as having 30 false people positively declared is a significant disadvantage. So, that depends on how physician will use the model. It is subject will be automatically prescribed when the heavy medication with a side effect, and false positive can be a critical thing. So, I do not have a corona, but I am detected with a corona, it is a false, but it is a positive sign. So, people will have a lot of medication problem, people will have a scarcity problem, and people get scared about the medications too. So, this is a problem. Okay. So, this is what we call, and these are all the we use a word called as a better way of using a model testing is what we call better way of using a model testing is what we call as a two term equal to, we define the word precision. I have a model equal to true positive, false positive, true negative, false negative. So, we define a term equal to precision. Precision tells me a true positive divided by true positive and false positive. So, precision will give me how many cases were reported positively, taking the total of all the positive cases. It can be true positive, it can be false positive too. So, this is the way a model works in our what you call as our matrix. Okay. And then we have a recall. Recall is, if you see here a recall is nothing but a true positive divided by true positive and false negative. So, I have a recall, and then this recall will give me a answer equal to this. So, this is what we call as our recall, and next time I am going to talk about a F1 score in more detail, because F1 score is a heavily used metric in our machine learning and deep learning algorithm, which will require some more time to understand. Okay. So, I will prove what is the meaning of false F1 score is equal to why it is coming as 2 precision into recall divided by precision into okay, precision plus recall. So, with this I stop here temporarily, and next session I am going to deal more details about the precision and recall in when we calculate the F1 score. Thank you so much.